We're going to call them separable equations. Sometimes they call it differential equation with the separable variables or differential, but separable equation, you understand. Now, different way to define it. One way to do it is this, okay? A differential equation is separable. So a differential equation, let's say of the form. This is one way we can organize the form. On one side of the equation, this is the notation of your book, dy dx or y prime. On the other side, you see you have a function like a g of x on the top and h of y on the bottom. You see those function of x and the y is like a factor. Because if you cross multiply this one, we get something like gx dx h of y dy. So those functions are going to be just as a factor. So if this is going to be the case, it's said to be a differential equation with a separable variable. It's called to have, if you like, separable variable. Separable variables. So cross multiply. Cross multiply, what are you going to have? You have h of y times the d of y. And on the other side, you have a g of x times the d of x. See? X and the dx together, y and the dy together. So integrate it. Integrate both sides. Of course, integrate with respect to each variables. Integrate both sides of the equation. So that's the integral of h of y, d of y is equal to the integral of g of x, d of x. That's it. Integrate both sides of the equation. Okay, that's it to find the solution. Solution of the equation, or solutions of the equation. That's it. So it's very easy case. As soon as you see those factors, you see they are going to be as a factor. Then you just put it together. When you integrate it, as soon as you integrate, sometimes it would be possible to solve for y. You don't have to. As soon as you integrate it, remove the y prime, you are going to give us the solution maybe in implicit form. Implicit form means x and the y are together. So if it's going to be easy, you can find y equal to. It's not, just don't bother. Just leave it as is. Okay, so that's it. Any questions? Yes.
We have to deal with a plus c and then find what the plus c is, or once we do this, we're done.
It depends. If they just ask you to solve the equation, there is going to be a plus c. So you just do the plus c, okay? Since it's a differential equation of one variable of first order, you get only one c. So you can do the c on one side of the equation. You have to have it on both sides, okay? And if extra condition is given to you, then you have to find this. Okay, so that's it. It's very tricky when you want to upgrade. So I give you all the possibilities, examples, okay? So this is going to be your first case. Just remind you the type of integral that we're going to have. It's very popular and sometimes tricky because you can make one as easily, as you can, as you want. Just put a couple of functions together and give us that one when they say solve it. Okay, so that's what you should have these various format. Okay, there you are. Solve each equation. We give you one of them in the next quiz and one of the S1. Solve each equation. That's the first one. One is dy dx And over there, we have the x squared, okay, 1 minus y squared. So you can see all the functions are as a factor. So it's easily seen that this equation has separable, or the equation is separable. Okay, solution, cross multiply. Just remind you that, just note that the equation is separable. The equation is going to be separable. And so solve it, cross multiply. Cross multiply, that give you 1 minus y squared dy equal to the x squared dx. You can put, I just put the y to the left. It doesn't matter if you want to put it to the left. That's it. Integrate 1 minus y squared dy. And over here, we're integrating x squared dx. There is nothing complicated, just the power rule would give you the result. Over here is going to be y minus, y cubed over 3. And over here is going to be x cubed over 3. And you can add the constant c. I'm going to add the constant c to the right. Even if you want to add the c1 to the right, c2 to the right, c1 minus c2 would be c again, because you are going to have only one constant, for this equation. It's done. It's done, some people like, it depends. If you don't like fractions, so multiply both sides by 3. See, that's some people, they like to do it, so it's optional. It's optional to multiply everything by 3 if you don't like fractions. So you may provide the solution as 3y minus y cubed equal to the x cubed plus c again. You see, that 3c and c is the same thing, because you have one constant. 3c, you can call it c1. So that's the best way you can provide the solution. And do that.
Can you move down the paper a little bit? Thank you.
Okay, so that is going to be the case. Let's put it out. So that is going to be the case. Any question? Don't try to do something else. You're done. You're done. The solution, it cannot be given in explicit form, and there is no extra condition, and we are done. That is type 1. Any question? What is going to be type 2? Possibilities for this one. What is the second one and the point about this one? The second one is dy dx equal to very similar 3x squared minus 1 and 3 plus 2y. Nothing special about it. Quickly, we identify that's a separable variable. So cross multiply and get the result. Because they are separate. See the x's and the y's. They're going to be mixed together, you can't do it. So quickly check it for yourself. So the solution is going to be, so it's a 3 plus 2y dy. And this is 3x squared minus 1 dx. And the integrations are a straightforward one. Just the power rule will give us. This gives you 3y plus 2y squared over 2. And over here, you get the 3x cubed over 3 minus x plus the constant c. Simplify it, is a 3y plus y squared on one side, and the x cubed minus x plus c the other side. Final answer. Okay. So this is going to be the case. Any question? You may have some trigonometric function, exponential function. So let's try some of those. So something with a trigonometric function. dy dx equal to 1 plus cosine x on the top, 2 minus sine y. Again, the function on the top and the bottom are separated. It's nothing to worry about. Cross multiply and get it right way. Okay, so again, it's going to be 2 minus sine y dy. This is going to be 1 plus cosine x dx. Separable variable integrate. That's a 2 minus sine y dy. And that's going to be 1 plus cosine x dx. And the integrations are straightforward. So integral of 2 respect to the y would be 2y. Integral of a sine would be negative cosine, so it's going to be plus cosine. On the other side, integral of 1 respect to the x will be x. Integral of a cosine is just sine. And the constant c, and you're done. Okay. These are the kind of straightforward, but no extra action is needed. Any question? Now the one that's going to be a little bit different, starting from this one. Number 4. So we expect this type of problems. Y dx equal to x on the top at y plus x squared over y down the bottom. Got this one? Yes.
Is that x to the power of 2y?
Yes. See on the other side that you have, should get those function of x and the y as a factor. You have the true x on the top, so that's a function of x. The bottom one, you have a mix of the x and the y together. If it's gonna be a separable variable, you should change this one as a factors. If you change it as a factor, then you can move them around. So if you have a function of x times the function of y, then you can divide by that function of x to separate it. So this is the way you think about it. Think about it that, can you factor anything here? Any suggestion? Y plus x squared times y. What's the common factor? Y. So if you pull out the y here, the leftover would be 1 plus x squared. Then you'll be able to separate it. Okay, so that's going to be your extra action that you're going to do. So if they are going to be as a product, then you can break them, group them together. So this is the way you think about it. So it's very popular case solution. That's it. We have the dy dx. Top is a 2x, that's fine. At the bottom one is not a function of y or a function of x, it's a mix together. So factor of the y. So that gives you y times 1 plus x squared over 2. You get this one now? Now this is what you are looking for. Look at the x's, see if you put these together. See? The 2x plus 1x, 1 plus x squared is a function of x. You may call it g of x. So the g of x is on the top and the y is on the bottom. Yes.
For the original equation, is it x to the power of 2y or is it x squared
no,
times
x
y?
to the x squared times y.
Times y, okay.
Yeah. X to the second power, then y. Okay, now you see, as soon as it's going to be like a factor, then you can arrange them together. There are different ways to do it. You can cross multiply first. Okay, cross multiply first, then try to arrange it so that you get the x's and the y's of both sides of the equation. But the idea is here, you see, 2x over 1 plus y squared is one function of the x, and the leftover is y, so it's separable. You can separate it as long as it's a product or the division, you can separate it. Okay, so cross multiply to get the idea how we're going to handle it. So that's going to be y. Okay, y1 plus x squared dy, and then you have the 2x dx. Just check to see what we're going to do next step. You see, this is the dy, so you should have only y here. And this is the dx, you should have only dx here. Any suggestion? Yes, divide by 1 plus x squared. Because this is an extra term for the y. Okay, we divide both sides by 1 plus x squared. This would disappear and come here, and then we get the x dx y dy. Okay, so this is it. We divide. Just remind you that I'm dividing. Okay, so that's going to be 2x over 1 plus x squared dx. Now this will cancel out. You know, it's non-zero. We can do it. So and then I missed the dy. So if you cancel it out, the leftover would be y dy. And this is going to be 2x over 1 plus x squared dx. Now, this is a separable variable. Okay, so this is very, very popular operation that you're going to do. Now integrate. Integrate both sides. Expect the corresponding variable, y dy, and integral of 2x over 1 plus x squared dx. Y dy is clear, y squared over 2. So that gives you y squared over 2 equal to, any suggestion for this one?
Natural log.
Natural log of the 1 plus x squared. Which is, when it's a rational function, you quickly check to see if the derivative of the bottom one is on the top. If you take this one to be u prime would be 2x. So that's a u prime u. U prime u would be ln u. So it's going to be ln of the 1 plus x squared plus the constant, okay, plus the constant c. You don't need the absolute value for the ln because, okay, because the 1 plus x squared is positive. Yes.
Do we take out the 2 in the numerator? So it would be 2 ln 1 plus x squared?
The rest are optional.
What does it matter?
Which one? Which numerator?
There's a 2x in the numerator in the step beforehand.
We
Oh,
need
you
that
divided
2x,
the other
no.
side by 2. Oh, no, that doesn't matter. The 2x in the numerator, when you,
No, you see, this is how we did it. We consider this one to be u. Okay, this is would be what? This would be u prime. Use u substitution. See, this is what
okay,
we have.
okay, yeah, I
It's
see.
gonna be 2x dx over 1 plus x squared.
No, yeah.
So that's a du over u, which is ln. Okay, so this is the way we did it. Any question? You're done. Here we came. And some people they go on. If it's going to be a problem in your book, you may see very strange, quite different solution. Don't be surprised. Okay, you're done. What's going to be surprised? You can multiply by 2, like algebra. If you multiply by 2, that give you. You don't have to. I just put it over here because I don't want to record it. So this is. So I have the y squared. You see, it's a y squared over 2. You don't need it because you've been asked to solve the equation and you did it. You can multiply by 2. So that gives you 2 ln of 1 plus x squared plus c. Okay, that's going to be the one. But some people even continue. They move the 2 up. They move the 2 up. That's it. Then they do something else. It's in this case, in fact, you cannot do anything else. They change it to the exponential form if you like. You can move the y squared y minus c, and then of 1 plus x squared, okay, all squared. Then use the definition of the ln function. That gives something like, something like this. But you don't need to do it to change it to those type of formats. You may have some formula in physics, mechanics, etc., dealing with the pressure, force, mass. Then you may do this type of operation to arrive at the target, if you like. And in this case, we're done. We ask from short question. And this is what we do. Okay, so this procedure is very popular. So just find it. I give you more. Any question? No. Next one. Another type that it may be given is this one. Number 5. This is, I think, one of the problem in your book. That's the x, y cubed, 1 plus x squared to the negative half. Look at this. So, it's a y prime. You can change it to dy dx first because we work with the differential rather than the derivative. So, solution. Let's do that change first. That's going to be dy dx equal to the x, y cubed, 1 plus x squared, negative half. We should look at this function to the right. The function to the right is given to you are a function of x and y, but they are as a product. See, they are all factors. So again, it's separable. Because on the other side, you get something like f of x times g of x. So it's possible to group them together to get a separable pathway, okay? Because you see, you put this x together to this one, x times 1 plus x squared to the negative 1/2 is a function of x, times it by a function of y. So again, when it's a product of a function of x times the function of y, it's a separable equation because you can separate it, okay? So to separate it, you will cross multiply first. dy equal to x y cubed 1 plus x squared to the negative half dx. Next, yes.
Because it's a negative exponent, could we put it in the denominator? and
Later,
Do a
later.
cross multiplying.
Later. Let's do the job of the, because you are going to lose that idea that what factor are you taking. Okay? So next step, what are going to do next? Divide by y cubed. Divide by y cubed. You should have a separable variable, okay? X's and the dx on one side, y and the dy on the other side. On the other side, you have a combination, okay? When we have combination, as soon as it's a factor, that's easy. So you have to get rid of the, you have to get rid of the y cube here to make it separable. Because this is a dx, you integrate respect to the dx, so you need the x's. You don't need the y cube. So we divide the y cube. And we are not going to worry about whether y is equal to the 0 or not. We can assume that it's not equal to the 0. Okay, so this is it. So this is going to be the dy over y cubed. So that's what disappears. So that gives me x times 1 plus x squared to the negative half dx. You see, that's a nice reciprocal. Y and the dy on one side, x and the dx on the other side. So integrate. Okay, integrate. So that's going to be integral of the dy over y cubed. And this is going to be integral of the x times 1 plus x squared to the negative half dx. So that's going to be the arrangement. Any question? Now you want to integrate this one, you know that you move the y cube to the top. So that gives you y to the negative 3 dy equal to integral of the x times 1 plus x squared to the negative half dx. So to the left, easy to integrate. You move the power up, y to the negative 2. Y to the negative 2 over negative 2 equal to, any suggestion for integrating this one?
U to the 1/2.
That's it, use substitution, for instance, something, if you consider this one to be u, okay, what is going to be du?
2x.
2x dx. x is already here. And the dx, we need a 2. So what we do now, we do it in quick way. We can divide by 2. And multiply by 2. Quickly create the u that you are interested in. Okay, this is your u, okay, and this is going to be your u. So basically, you're dealing with the u to the negative half. You can do the substitution, but get used to it because this is going to be used quite a lot. Most of the time, the number is missing. If the coefficient is missing, we can create it. We create it and we go for it. Okay, so I needed 2, 1/2, 2. Now this would be like u to the negative 1/2. You know that integral of u to the negative 1/2 would be what? It's going to be u to the positive 1/2. So we continue here, the same thing. So this is going to be y to the negative 2 over negative 2. And this is going to be 1/2. And on the other side over u, which is 1 plus the parentheses, you raise the power. Negative 1/2 plus 1 with the positive 1/2 divided by the 1/2 plus the constancy. Okay, so that's integral of 1 plus x squared to negative 1/2. Simplify these two would cancel out. We don't like again negative power, you bring this one down. So that gives negative 1 over 2y squared. Okay, negative 1 over 2y squared. And on the other side, just simply 1 plus x squared, 1 plus x squared to the half. That's the constancy. It's done. You know, if you like to change it to the radical, it's up to you. It would be fine, but if you like to have a nice one, so that would be the final answer. That's the best we can do. Okay. So as long as you have a product of two functions, the product of a function of x and a function of y, you'll be able to do it. Or if you need to factor something, factor first, then separate it. You separate it by, getting rid of the extra terms that you're going to have. Okay, any question? A couple of more involved. So that was the number 5. So this one also, it's very similar to the one I did. Just remind you the drift of the inverse function we're going to use from time to time. So number 6. Number 6 is this one. How about y squared times it by 1 minus x squared to the 1/2 dy equal to sine inverse of x dx. Now that's similar one. So we got this one. We check to see what type of the equation do you have. You check to see if it's separable. To the right, x and the dx can together. To the left, you have the dy, so you need only y here. But the leftover is just a factor. Since it's a factor, we can do it. What are we going to do first? Divided by 1 minus x squared to the 1. Okay? Because you have to have the key. So this is it. So divide 1 minus x squared to the half. So you're going to lose it here. So they'll give you y squared dy. You divide on the other side. Give you something interesting that sine inverse of x 1 minus x squared to the half. Now it's separable. You see x and the dx, y and the dy. So it's a separable, and we can integrate it to get the result. So integrate y squared dy, integral of, that's the sine inverse of x. I change this one into the radical to be more familiar to handle it. That's it. Integral to the left is easy, y cubed over 3. About the one to the right. You remember what's a derivative of sine inverse? 1 over
1 plus x squared.
1 minus. See, derivative of a sine inverse is 1 over radical 1 minus x squared. Already got it here. So this, you look at it as, you see, this is how we look at it. It's a sine inverse of x times it by 1 over 1 minus x squared dx. See, look at this. So if you take the sine inverse to be u, this is simply du. So you're dealing with integral of the u du. You know that integral of u du would be what? Would be u squared over 2 plus c. Okay. So what's going to be your answer? So this is going to be y cubed over 3. Now this is going to be u is sine inverse. So we have to write it in new form. Sine inverse of x whole squared divided by 2. That's the constancy. Okay, I just use the u substitution over here. U is the sine inverse of x. 1 over radical 1 minus x squared dx is du. So that's it. That's your du. So you're integrating u du. U du would be u squared over 2. You know, but you can get rid of these fractions if you like. You can multiply both sides by 6. If you multiply by 6, you don't have to, but if you like to simplify it, so 6 and 3 simplify, that give you 2y cubed. 2y cubed, and this is going to be 3 sine inverse of x all squared plus the constancy. That's formally the solution of your equation. It's very popular case with the sine inverse. That you will see this one. Good question. Couple of more, okay. Exponential function for this method is very popular. Okay, a couple of cases for this one. So get used to this type of idea. We have done it for calculus. In calculus 3, we do it when we did the integration. The double integral type. There's something similar here. Okay, and this is the case, dy dx is equal to the e to the 3x, the top, plus 2y. dy dx equal to the e to the 3x plus 2y. Any suggestion?
We separate the e.
Separate the, very good, yes. Separate the e, that's the case, yes, excellent. So separate the e, solution. Because you see x and the y are mixed together. So you cannot do anything about it as is. But when you separate it, you give it a chance. So the separated means this is going to be e to the 3x times e to the 2y. See, that's the one. So you separate the function. You see, you have a product of two functions. One function is a function of x, the other function is a function of y. So quickly, that will tell you that it's a separable equation. Because whichever you don't like, you can divide and get rid of it. Okay, so that's the idea. So cross multiply those differential. So that gives you dy equal to the e to the 3x, e to the 2y dx. So since you want to separate it, you need the x and the dx together. So from this side, this is going to be an extra term. You have to get rid of it. To get rid of this one, you know, you divide the both sides by e to the y. So divide by e to the 2y. Because then you bring it here, that's fine. Because here you have the y and the function. So if you divide it, so that give you dy e to the 2y. And here you get the e to the 3x. Now you have the separable variable. The integrated, even you can move this one up because eventually you have to do it. And you want to integrate it. Okay, so you move it up e to the negative 2y dy. And this is going to be e to the 3x dx. That's now much better. Okay, so quickly integrate it, and that give you the final answer. Okay, any question? Going to go to the next page. Continue, integrate both sides. This is respect to the y, respect to the x, use up, and that give you the result. Okay, so this is going to be the result. Integrating, so we have integral of e to the 2y dy on one side, and integral of e to the 3x dx on the other side. Okay, easy to go. You know that differential exponential function never change. It's going to be the same thing, e to the negative 2y, and you have to divide by u prime. The prime derivative of the top, which is a negative 2. On the other side, the same thing. Exponential function never change, so it's going to be e to the 3x, and you have to divide by the u prime, which is 3, and the constants. Okay, when you differentiate, you multiply by u prime, the derivative of the top. When you integrate, you divide. So this is the way we can quickly do it. Again, you know, if you don't like this numbers, it's optional, but you better multiply by, multiply by 6 to simplify it a little bit. So that gives you negative 3 e to the negative 2y, and that gives you 2e to the 3x plus the constant c, and then do that. Okay, so exponential part and this breaking it is very popular. You will see it again. Get to the some other sort of equation. So keep in mind that when you break this one to get these numbers. You have one nice one in your book. Even the power is something like sine x, cosine x, etc. It's the same thing. Okay, any question? Yes.
You have to simplify every response.
This last one?
Yeah.
No, it's done. What do you want to do about it?
What was that?
What do you want to do about it?
Nothing. Nothing.
Yeah, it's okay. Some people they go for it. Some people they really do it is, they just change this c so that all those e functions are going to be the same. Then they'll be able to get rid of it. So don't be surprised if you check the solution in your book and you see something which is very different. This means you have to go on. But for our case, no. The most we do is this one. Okay. Any question? Now, there is one more tricky one that you must know how to do it. Have a couple of them in your book. And I put one in your. You can check that practice one that I posted for you. Practice quiz number 1. Question number 1. They are all separable. I have 8 to check. So quickly check it tonight. Just make sure you know it. One of them is this one. Very similar to it. This is very popular. Let's see if we can do how we're going to do this. So this one, dy dx is equal to xy plus 3x minus y minus 3. The top is xy minus 2x plus 4y minus 8. You see, look at this one. To the left is dy dx. To the right, remember, you can do it if the right is the quotient of two function of x divided by function of y, or it is a product of two function of x times the function of y. This is the two cases that we're going to have, okay? But as you can see, top and the bottom are mixed together. Any suggestion? Yes.
On the top, you can pull out an x and -1, and then what's left is y plus 3. And then
Yes.
on the bottom, you can pull out an X and a 4, and then Y minus 2 is left,
Yes,
and they're multiplied.
it means you are going to factor it using grouping method. Okay, because you have 4 terms on the top, 4 terms on the bottom. So you have to group them together to be able to factor it as a product. You see this one? Yes, that's right. These two together. Xy plus 3x, the common factor is x. You pull out the x. It's going to be x times y plus 3. Then you have to make y plus 3 out of the other. So negative y minus 3, you factor out negative 1. Down the bottom, the same thing. Okay, so group them together. Use grouping to factor it. Because you have to factor it, otherwise you can't do it. So this is it, dy dx, start factoring. So for the first two, we factor x out. So that gives you y plus 3. We need y plus 3 for the other, so put out the negative sign. The negative 1, so that gives us y plus 3, so that will be fine. So we have the common factor. If you like, you see this would be equal to, the common factor is y plus 3, and the leftover is x minus 1. So we get a you get a product of two functions, x times 1. Bottom one, common factor over here would be x. So we get the x out, so that gives us a y minus 2. Common factor over here, you see you need a y, so we pull out the 4. So that gives you y minus 2. So we have a new common factor, which is y minus 2. So this is going to be y minus 2. Y minus 2 times x plus 4. You see top and the bottom are the product of separated function of x and function of y. So this means this equation is separable. And you have to arrange it. You have to arrange it yourself. You better cross multiply, then find out how you're going to group them together. Okay. So cross multiply. So it's a y minus 2. Okay, that's it. This is how we cross multiply. Y minus 2 times x plus 4 dy, okay, equal to, over here, it's a y plus 3 times the x minus 1 times the dx. Okay, so I just cross multiply dy dx. Now group them together. Group them together carefully, because you have the dy here. So you should get rid of the x plus 4. So you have to divide by x plus 4 to get rid of this side. But on the other side, you have the dx. So you have to get rid of y plus 3. What you have to do is you have to divide both sides. Okay, so you have to divide. Just remind you, you divide by x plus 4. X plus 4 times that by y plus 3. Divide by both sides to simplify it. If you divide it, what's going to be the leftover? The leftover over here is going to be, we keep the y minus 2. And we divide by y plus 3. So we get a y plus 3 here. dy equal to, on the other side, we need this x minus 1. So it's x minus 1. We get rid of here by dividing, okay, that's it. We do the x plus 4 here. X plus 4 dx. Okay, this is the way we put them. If you cross multiply this one, you get to the original one. And now you have a function of y and you have a function of x. So the equation is going to be separable. So take the integral of both sides. See how we're going to handle this. Okay. So integral of y minus 2 over y plus 3 dy. And this is going to be integral of x minus 1 over x plus 4 dx. Rational function to integrate it. Okay, what's your suggestion? to do a trick to do it. Yes,
Long division.
yes. You can do the long division because you know the degree of the top and the bottom are the same, so you have to divide. You know that if the degree of the top is equal or higher, you divide. But you can use a trick to simplify it more quickly. Yes.
Do we like separate it so it's y over y plus 3 minus the integral of 2 over y plus 3? And then the same on the other side?
No. No, that would be a long procedure. Eventually you will get it, but it would be long. No, you can divide it, or you see, or you say this is y plus 3. Create y plus 3 on the top, then break it.
Right.
That's the quickest way to do it. You see, let me just show you how to do it. This is y minus 2 over y plus 3. So I like y plus 3 here. This is my y plus 3. I add the 3, so I subtract the 3. So that give me y plus 3 minus 5. It's like a long division. It's the same. I break this one. If you break it, it's going to be y plus 3 over y plus 3, which is 1, minus 5 over y plus 3. Okay, which is eventually would be 1 minus 5 over y plus 3. Now I can easily integrate it. Okay. We can do the same thing to the other one, x minus 1 over x minus 1. And if you don't like it, just long division. Look at I show you the long division too, so you can see it. If you want to do the long division, is how many y plus 3 are going to be in y minus 2. If you divide, y plus y would be 1. Then 1 times y would be y. 1 times 3 would be 3. You know that we switch the sign. Then we add. That's a negative 5. So the quotient is 1. The remainder is 5. It's a negative 5. That gives you the same thing. When you divide, this is going to be the quotient that you get over here. And this is the leftover. And you know, this method is easier. And you're going to do it a couple of places, even when you do the Laplace transform at the end of the course. So it's going to be a run step of procedure. Okay, quick one. And of course, we divided if the power of y is higher. It's going to be y cubed, y squared, then you divide. Okay, so this is the one to the left. You can do the same thing to the right. Okay, to the right, again, you can divide or you can break it, whichever you like. So to the right is x minus 1 over x plus 4. I like x plus 4, so I create x plus 4. Then I subtract the 4. It's going to be minus 1, and it's going to be x plus 4. So it's going to be x plus 4 over x plus 4 minus 5 over x plus 4. So that gives you something similar. 1 minus 5 over x plus 4. So if we go back, substitute, natural log would take care of it. Okay, write it down, so I go to the next page to finish it. So we have another type of the equation, we call it homogeneous. Later on, we use this rational form over there. Okay, so I'm going to the next page and replace it like this equal form. With on both sides are 1 minus. So this is how we change it. So it's a 1 minus 5 over y plus 3. That was this one, dy. This is 1 minus 5 over x plus 4. Okay, you integrate it and give it the final answer. And so integral of 1 respect to the y would be y minus 5. You know that this is going to be ln of the absolute value of y plus 3. Natural log. derivative of y plus 3 is 1. Same thing on the other side. This is going to be equal to the x minus 5 ln of the absolute value of x plus 4 plus the constant c, and then do that. So this is a kind of very, very popular case that you have to know it. You get the experience of this operation, algebraic operation that we have to do from time to time. Okay, any question? You need to give me one more to finish it. And all this equation that we did, we find the general solution. You may be asked to find a particular solution of one. Okay, some initial condition will be given to you. You do the same thing, but at the end, you're going to find that constant c for us. Okay, so this will be our last case for the separable. Example. The expression that they use, say solve the initial value would begin, so we call it the initial value problem. It's a problem with the given initial condition. So y prime is 2 minus e to the x divided by 3 plus 2y. Initial condition of y of 0 equal to the 0. So this means the graph of this function is passing through the origin. And x is equal to the 0, y is also equal to the 0. So you solve the equation first, and then you substitute these numbers to get this. Okay, easily seen that it's a separable equation. On the top is a function of x, then the bottom is a function of. So switch to the differential form and get the result. So differential form dy dx, that give you 2 minus e to the x, 3 plus 2y. Cross multiply. With 3 plus 2y dy. That would be 2 minus e to the x dx. Everything is nicely done. So integrate and get your result. So 3 plus 2y dy. And this is going to be 2 minus e to the x dx. Okay, integral of 3 respect to the y would be 3y, and that would be 2y squared over 2. On the other side, we get the 2x minus e to the x plus the constants. Simplify, then apply the initial condition. These two will cancel out. So we get the 3y plus y squared equal to the 2x minus e to the x plus. Okay, so this is the one that we call it the general solution, because you have many solutions. Okay, so this is the general solution. Any question? Since you have the initial condition, you have to continue. We begin y0 equal to 0. This means you let x equal to the 0, y equal to the 0 in the equation, and you find the c. Okay, so that y of 0 is equal to the 0. So there's x by 0, y by 0 in the equation. So that gives you 0, 0, 0. This is going to be 0 minus e to the 0 plus c. So we get the 0, e to the 0 is 1, negative 1 plus c. So c is positive 1. Go back, substitute, that gives a particular solution. So the final answer is this one, 3y plus y squared equal to the 2x minus e to the x plus 1. It's going to be a particular solution of the given equation. Yes.
Does it matter which side the one is on? Because depending on which side you put c on, does it count with the negative?
No. Because this is implicit solution. okay, you are not going to give us exactly the y. So okay, that's it. That's separable variable, 2.2. You can have your break. We come back, get them a very good one. Next class is linear equation.